take it from the introduction. I am from Qualcomm, and it's my first time to attend this kind of conference. And actually, Qualcomm recently have later to encourage our engineers to do upstream first. That means actually Qualcomm will take more and more effort on upstream to align with the upstream compatibility, upstream UHI. Also, we wanted to upstream our features, patches into the upstream. So that's why for scheduler, actually we do have a WALT scheduler. And this WALT, actually it changed the PLT to a window-based load checking. So on top of it, we also have some scenario-based like benchmark or mobile gaming scenarios, those kind of enhancement features into the WALT. Also the WALT CPU frequency governor. So actually we wanted to see how we can make the next step, like do the WALT upstream, both the scheduler and maybe CPU frequency governor as well. Yeah.
My question is, what is the difference between WALT and PELT? Because isn't that basically doing the same thing? You know?
Basically doing the same thing, same for load checking, yes, and it is still per task. So for the task load checking, actually the Windows based, that means, for example, we have the frame, it's like 8 milliseconds frame for a screen refresh rate, for example, 120 Hz frame refreshing. And actually the load checking, that means the scenario, it will likely have 8 milliseconds how to say period task similar behaviors. So for example, if we have a similar window size, the load checking, for example, it may have the scenario more compared to the real scenarios, something like that. Yeah.
So it's been a long while since I've seen this stuff.
2017. That was when they last pronounced it in LBC.
Yeah, it's been a while.
9 years.
So we use PELT for two major things. Its original purpose is the C group load tracking. And then we've got all the energy aware and CPU util and all that stuff on top of it. The problem with WALT was that it was too fast for the C group stuff. It's too ready to discard history in order to be fast on the now. And that gives very erratic C group weight behavior. So from that respect, I don't think we can replace PELT. And that would mean we need two means, and two is too many.
Well, this might actually go hand in hand with sort of my scheduler governor ideas and stuff like that, because
No.
The reason why I'm saying is a lot of things.
There is already too much proliferation.
No.
People are all doing their own.
No. The problem is this: the Linux kernel has been basically focused on server workloads. Everything is based, that's where all the money comes in. So basically, most of development, everyone cares about benchmarks for the servers. You have Meta, you have Google, you have Amazon. All these guys care about these, their machines running really, really well.
Well,
And
Google also has this Android thing and the Chromebook.
And guess what? They're finding out that things aren't working very well there. This is why there are these are the groups that came up with or pushed for SCEDX. These are the groups that pushed for changing things.
SCEDX is not a solution.
No, exactly. That's why we need something. The thing is, focusing on like the server side, you can't make the server fit on an Android, on a phone, and a laptop. It just doesn't work. Where this is kind of the reason why WALT does so well is because an Android is for a specific purpose. It's for games. Games perform so much better with that.
So for that, I'm curious to see some figure. The last time I have seen a comparison between PELT and WALT, the conclusion that was that WALT was not better. It was mainly the added value on top of WALT. So when you're saying it's better, because it's not only the load tracking that changed, but everything around.
Right.
And I'm curious to see any difference between PELT and WALT from a pure load tracking mechanism. Because I agree that for 8 milliseconds you will have, but then if you're not 8 but 16 or 24, then you screw up your load tracking.
That's why 8 milliseconds, it also aligns the CPU frequency timer window, the same window for the CPU frequency government as well.
Can you maybe tweak the decay in PELT to match your use case, probably?
The decay is done every, you don't have any half-life. You just, for each 8 milliseconds, you look and then you forgot the previous 8 milliseconds.
Is it not about the
So my point is more that I haven't seen any, I would be curious to see what is better on WALT compared to PELT without any other scheduling feature, just from a load tracking.
It could be
Because at some point, so we have been asked to increase or to decrease the half-life of the PELT.
yeah, exactly.
But some people have complained that sometimes it was too reactive.
Yeah.
So then they wanted some case to increase the PELT half-life. So I'm pretty sure that you will face exactly the same problem. Your 8 milliseconds is probably good for gaming at 8 millisecond frame sync, but then in some other case, people will complain that you will increase too quickly the frequency, or you will migrate to the big core, and then you probably have some additional sketch feature that I would say compensate this, which in fact, WALT is not better. WALT is better because you are filtering on top of that. You see the point?
So the question is, can you filter on top of PELT?
My point is that what is better? Is it the all added value out of the main line, or is it really WALT versus PELT? So, and I don't think that WALT is better. Probably not worse, because it's two load tracking mechanism with their own, I mean, say, drawback advantage. But I don't see WALT by itself being better for scheduling.
I share the same opinion, Van. So we've been there trying to speed up the PELT, and then we face another problems with too high power because it's too fast ramping up. But for me, it looks like, so we are trying to solve maybe a different problem with the old signal, which is the latency problem. So if you are focused on the latency, we have this tuning now for this EVDF, the latency, but how we can express not the throughput, which is this, let's say, PELT signal, that's kind of measuring the throughput. But if you are focused on the latency, there is no metric in the tracking system for you. It doesn't express that you are focused now on the latency rather than the computation over time.
By latency, you mean how fast you would like to run, or?
No. How fast the system should be for you.
Response time?
The whole devices. So we ramp up the frequency, and as a side effect, we sometimes ramp up the frequency not only for the CPU but for the caches as well. So it's kind of
Frequency.
Yeah, the frequency. So you get the latency from the hardware by some side effects of utilization or this uclamp mean. So this is kind of the artificial boost for the hardware just for this latency sensitive task in the game.
Mhm.
And I think so. The utilization is not the best to modify WALT versus PELT. It's old discussion, but I think we need to have something new.
But that being said, if you see any problem on PELT, just come on the mailing list and raise what is going wrong, and we can try to find a solution.
So yeah, that will be my point. Like, start with a problem statement. And say this doesn't work. and then in addition to that, you may say one of two things. Either this is how I fix it, right? Or I have this alternative thing that works better for me in this use case. And then other people can look at it and, and then figure out.
Right, so if you want this,
start with this.
so basically, if you want this upstream, the thing is, you have to have the argument, why is this better than what already exists? And can what already exists be modified to make it as good as what you have? So instead of just coming up with another solution or something, you have to present it with that. That's how they get it upstream. So you can't just say, hey, this works great for us. You have to convince the upstream maintainers that it's going to be great for them.
Yeah, normal rule is like this.
Yes.
It's only that Qualcomm have many years working on WALT already. It's now it's getting very bigger. So yeah, I think I can. The comments is right. Please, like we should compare the PELT and WALT only for load tracking and to see what's the difference there. Yeah, I think I can take that comments back, and also I also wanted to check any suggestions like for example we also have the schedule extension, like should we have some it is scheduling extension is make the experiment more easier, and yeah, maybe we can also have the generic thing and the scenario-based features split into different areas, like maybe for the, if, for example, the WALT, it is too scenario-based, maybe it is suggested to go with the scheduler extension itself. That's a question.
SCEDX?
Schedule, yeah, schedule.
I don't understand that the whole SCEDX prototyping is easier thing. I mean,
Limitation.
how hard is it to just write C? I mean,
Well, you're okay. So basically, you basically wrote half the scheduler. So of course it's easy for you.
delete most of it and start over. It's really not that hard.
I mean, it's still C code. It doesn't. I mean, you can do that in.
So what's the advantage? You just if it crashes, you fix it. You try again.
Yeah, so both ways are identical, I would say.
So then, yeah.
Even with SCEDX, that would suggest, start with a scheduler that already exists, implement WALT or PELT. We already have a PELT re-implementation. Replace that with WALT, but you can do the same in the core scheduler. Like it's still C code.
So I just don't understand the SCEDX is easier to prototype argument. I don't think it is.
It's easy that if you want to rapidly load, unload, it crashed, I don't have to reboot, then it's easier.
That's what we've got virtual machines for.
Oh, yeah. I mean, you can, it's up to whoever does the work.
How specifically virtual machines are annoying?
Virtual machines are absolutely annoying, but they're great for smoke testing.
Use VirtMeNG. It's
sorry, Vassan, going back to your point of comparing purely the two tracking mechanism, how would you define better? I mean, how can you compare if you're not looking at how?
I'm curious to see how you can say that Road tracking is better.
But actually, I would say something.
Yeah, but if it's a tricky question, there is no point in doing the comparison. I mean, I think we
Well,
won't.
Well, obviously, okay, do you have like game benchmarks or something? Do you have something that you use to benchmark or have a game benchmark to figure out how to improve like WALT and everything? I'm assuming internally or something, you have something that you can test to say, hey, 'cause obviously, Qualcomm, especially for the Android phones and for Chromebooks coming up, they're very specific to make sure they work powerful for certain games, stuff like that. 'Cause that's basically the use case of people who have phones and have Chromebooks. So
Isn't that what you
people
have a PlayStation for?
No, people don't buy PlayStations anymore. They use their. I don't know. I'm saying no. People do actually like. You mean your kids don't play games on the?
None of them have a phone.
Oh, okay. You're a good parent. So the point I'm saying is that a lot of people like really do buy. I have friends that are gamers. They do buy their computers and stuff like that based on how well they know they perform. So yes, to sell Chromebooks, sell phones, they want good performance out of the games that people will be buying.
Chromebooks
them
don't
for.
even have memory. How can you game on those things?
People do. So the point being is, just because you don't doesn't mean other people don't. So the point I'm saying is that they are from Qualcomm, from a business standpoint, they're trying to focus that to sell their hardware, and they modify the software to make it perform the best. So I'm assuming there's like benchmarks on how to make things work better for their use case to sell more products. That's going to be, I guess, right now they're saying PELT didn't do it for them. They came up with their own WALT thing that they actually were to specify there. Now the question is, can we make PELT as good as possible? So that's the question. If you guys have a benchmark that you use to sell more of your hardware, show that to people saying, hey, this is kind of like.
But I think if I understood well, Vincent, the point is that it's not only the benchmark itself, because I mean, I guess there can be walls, but other like things that are changed and they require wall to function properly. And then if you just compare WALT and PELT, it's not even fair. Right. Then you're still missing the plus.
There was a presentation in 2018 about PELT versus WALT done by a Qualcomm engineer. And from the output, the main difference were the added value more than PELT versus WALT.
Yeah, and I think that's because they have a lot of hooks. And that's from my understanding is that Qualcomm has built a huge, technical debt on top of WALT.
And the conclusion was the goal was to try to put the added on top of PELT to see what's the gap finally. And at the same, the PELT signal 8 years ago and the PELT signal now, it's just night and day. I mean, there are so many different that the other thing. I mean,
so that's, I guess the question is, have you guys actually even looked at PELT and seen if you can take the technical debt on WALT and see if it would work on PELT as well?
So first question is for benchmarks. Yeah, and actually we are using the real use case like the game. We're using the game replay and to make it have a consistent output of performance and power together. And for the non-game use case, for example, we have like TikTok. Also, in China, it's called Douyin. So there are many people now are using flashing those small videos very frequently for hours a day. So those
human life.
they're wasting life. Yes.
Well, it makes money for us.
You should be ashamed of yourself.
We are past peak humanity. Doom scrolling ABI, let's call it. Right?
This is horrific. This zombie factory. Oh my god.
I don't know, with an arm.
You see what would possibly the problem.
Some form of videos for it's not TikTok, but obviously like something that loads a new video every 2 seconds or whatever. And I haven't done any like WALT versus PELT comparison. I think like also making the direct comparison isn't that easy because arguably PELT also has some value adds. And like, do you want to keep them or not? Like, what do you actually like? What are you comparing? I don't know, but I mean, finding a benchmark, be it like some form of video scroller or whatever. That can't be hardware.
Yeah, that's why I'm asking. I mean, you can always tune something for your use case.
Yeah.
Tune all the paths from the display to the load tracking.
Yeah.
For your use case now, which part is really the load tracking, which part is the scheduler decision, or even the optimization of your frame buffer? That's then another story. How you split your game.
Because I mean, I presented something last year based on this video scroller thing, and I also saw that every time you switch the video, you are in an inefficient frequency for quite a while. But I don't know if WALT is necessarily better than that, because obviously that PELT has a nice property of being smooth and being more stable. Placement, therefore, as placement. Hard to have a good impression on that.
Yeah, there's also the fact that, you know, like you try to measure like how accurate you are. Sometimes maybe you perform better if you're less accurate. So it's hard to define a metric.
Too bad.
Yeah, exactly.
You can
Signal
always
can make the result better.
boost the frequency if you touch the screen. For example, I don't know, but yeah, so PELT being a smooth signal is very beneficial for the C group load tracking. That's more or less the reason it is like it is. If you replace it with WALT, that goes out the window.
But even that, I mean, we have been asked to reduce the half-life period.
For C groups?
Not for C group, but for PELT. And then some people were complaining that it was sometimes too reactive.
Yeah.
So.
Do you remember what workloads were too reactive? Because those are good
all
counters.
the low power use case, for example, MP3 playback.
Yeah.
So you wake up, I don't know, every 20 milliseconds for a few milliseconds. So
and then you ramp up too high.
That's the point. I mean, sometimes you want to be reactive, sometimes you don't want. But in this case, more than your load tracking, I can understand that your load tracking is, I agree that with a 32 millisecond half-life, if you want to track a 1 millisecond change, it's not possible. So we can probably reduce to 4 millisecond half-life cycle. But I'm pretty sure that people will then complain that we are reacting too quickly. In this case, it's not the tracking mechanism, it's how you use that.
Yeah, I think when you want to reduce your, I mean, the goal for you is to reduce your technical debt on top of mainline. If this, I mean, this would be a fine goal. Just take PELT and then you just do like a half-life reduction of 60 milliseconds and look what you have to do the work, right?
I guess the idea is in this to sell it as like for a manager thing for basically again technical debt is the main issue, and you have to make sure that it's worth it. So you have to show that you can do it on PELT because it's going to be a huge effort to switch everything over to PELT. And if you do that effort and then find out that you're not as good as what you were with WALT, people are going to get fired. So the idea is to prove that it's a worthwhile thing to do. So it's not all technical.
But someone needs to actually do the work.
Yeah, which would have to be Qualcomm.
Right.
Because at the opposite, you can say, okay, WALT is better, we move to WALT, but WALT is better only because added value. Then the added value never get upstream, and you have the main line with the worst load tracking, but not the added value on top. So that's why we need to have a full picture.
Yes. So basically, can all the added features be added upstream? I mean, is that, I guess, but is that user space sites too, or?
I don't know. I don't know exactly what are the added value. I know that it gives some benefit, but I have no idea what it is.
Because I wonder if it's tied to like if it's like for the Android phone, if they have their own Android setup, they could see how the user is interaction and change things based off of a lot more input from user space.
Yeah.
So like you said, sometimes you ramp up too quickly. Well, they might know that this scenario you don't want to do that. So
the game engines knows it'll do massive amount of particle effects. The game engine knows how many stuff it will render in the next frame. If it could tell us,
so maybe that would be a worthwhile scene. Try to add the added value upstream.
Then we don't have to guess.
it's not only about the game engine, Peter, it's about the other engines as well, like from the browser. Well, but they cannot express this right now.
Yeah, so but we've been asking for this for donkey's years now at this conference, is tell us what information is important.
Yeah, yeah. But how we can express something like for the garbage collector that I'm latency sensitive now, please ramp up those memory subsystems or whatever. As a side effect of this frequency boost, you will get them.
A garbage collector, who uses that?
Well, Java programmers.
Well, yeah,
Well, I mean, if you want responsive interaction, don't use a garbage collector. Those two are diametrically opposites. So either you care about responsiveness or you care about ease of memory
well,
management.
actually, but no, believe it or not, people care about both. So it's like, I hate to say this, that's the real world. And the thing is, you're asking us, the ask is always like, tell us, but sometimes you say, give us more details than they know. They're not scheduler experts. They just say, I know this application gets fast.
Well,
That's what we're working on.
I mean, they've built this entire ecosystem on top. So
Right.
supposedly they actually know something.
Well, wasn't Case was supposed to be here?
Yeah, maybe tomorrow. I think it was
Tomorrow. Well, he's working on the libQoS. Is he giving a talk on it?
no, but they should be here probably tomorrow because I think it was traveling today, so I couldn't.
Okay, so the libQoS is supposed to basically make things a lot, just basically have configuration saying, give properties saying this is interactive, this is this, and then the library will supposedly do all the tweaks to tell the kernel this is how you need to act. So from the application developer, they just say this is interactive, just be fast. When something touches. So that's all the application people care about. So we need a layer to translate simple, characteristics of an application down to the kernel.
So Peter, in Android we have this uclamp min to compensate the problem with the slowing ramping up on PELT. That's heavily used in Android. You can set this for C group if you like. So by definition, you will get something.
Yeah, even that, I think at some point, that's something we have already discussed, is that for subtask, instead of trying to estimate, we already know. In the display pipeline, you have 8 milliseconds, you want to run 1 millisecond.
Yes. That's why
WALT of it, we don't care. 1 millisecond every 8 milliseconds. So
yes.
Just set the value and that's it.
And that's how Android did that for some services like media server or those display related stuff. They get the uclamp upfront. And that's the decent value for this.
That's also I was trying to do, to use the sched attribute with the runtime, with the slice, and the deadline to replace the utilize with this value directly.
Yes, but so we have something on top of that with a uclamp min, for instance, for Android. I'm not sure if they have something for WALT, something like WALT min, or I don't know.
uclamp.
Yes, uclamp min. We have something like this in the kernel. This is the minimum utilization that you will get from capacity of your CPU. So this is actually asking for minimum capacity. So you are likely to land on a decent CPU. So try to avoid some low capacity CPUs, and then also get the frequency immediately.
uclamp can work together with WALT.
Okay.
And we also have customer use the uclamp interface.
I see.
That part is. Yeah, so like that low latency, we have the user space in place to tell, for example, this group, this task it should be have a low latency attribute.
So you basically have like a quality of service library or something, or some interface.
Yeah, we do have some interface from the user space hint as well.
Mhm.
Yeah, so yeah, that will have the hint from user space, and the scheduler take that hint. Like the uclamp can be also, for example, we have task boost. So this task will always go to prime CPU.
Okay.
Something like that. Yeah. So there are many kinds of features. So some is generic, some is scenario based.
So
Yeah.
so this is the point from Vincent. You have something on top. If we don't take it, then there's no other point to take the WALT without this extra goodies, because the WALT versus PELT, it's not.
So basically, here's something like just for added effort. If they could show like open source or make sure like everyone could see what those added value is for WALT. And we could say, hey, if we add the added value, it makes things so much better. Then maybe you could have a collaborative effort, not just Qualcomm, but other people to say, hey, can we get these other add-ons to work with PELT? Because that will benefit everyone. If you had that, I think if you have like some sort of interface that interacts with WALT that makes everything better, could we do that same interface for PELT? So we don't have to rip out everything that is already in the kernel.
It's open source.
Yeah.
So they might have something like those flags like prefer idle CPU. We don't have that in mainline, right? But you know, those are the goodies that you mentioned. There are some, let's say, QoS knobs, which that would be hard to take like to mainline. But they are in the same area of quality of service, I would say. So, and we cannot express the latency need currently in the mainline.
Not only prefer idle, also we have some idle checking together with scheduler. So check the CPU current idle duration and then try to use that for scheduling as well.
Okay.
So you said all these value addeds are open source, correct?
Open source, yeah.
Are they published where someplace that we could just like take a look at them and?
I'm sure. I think it's open source. That is at the CLO. It's totally GPL-v2 licensed, so it's all open source.
As I said, if we have that, maybe if we can start looking at seeing what they do, maybe we could start modifying the quality of service stuff.
Yeah.
Because it sounds like they've done the effort to do, and they have like 10 years of effort on top of this.
My thought is only about comparing Apple with Apple.
Yeah. So maybe it's not, maybe you could get more, like focus more on getting value added stuff pushed upstream more than just WALT. So,
yes.
Yeah, so is there a rule like which kind of feature is scenario based? It's better to go with schedule, yes. And which kind of feature, for example, it is common enough, for example, common enough to go into the main scheduler. Yeah, so that is a question.
Sometimes to answer this and tell this to people so that they understand, so it's more work than to keep it as a value add in-house. It's a lot of work to convince people because you have your own, everything is proprietary, and then if you have scenarios you explain to others, how can they verify this, right? Sometimes this kind of work is much harder. That's why also Google has a lot of extra stuff on top of mainline. I'm just saying like aggregation of UTM max, etc. And we started to discuss it on mainline, and then I think the company realized it's so much more work than just to keep it in-house and even though they don't want to, but at the end, it's.
Yes.
So I
suppose the AI can make it more easy.
I think if we would go further, then we need a decent open source platform so we can all agree with the platform and testing results. Then we need this day of usage from you, those applications, ideally automated so we can just check the change.
And this is the expensive. This is the expensive stuff. And just to share it with everybody, it's not possible.
And we lost that ports basically from recent hardware generations, so there are not that many to verify this code.
So there is information like, for example, our Qualcomm upstream very early now. For example, last year September we have our Kanapali, the announcement in September, and we have the first patch series to support that SoC uploaded in one day. So that is Qualcomm's attitude to make the SoC platform as early as possible. we have like I cannot remember the exact patch numbers, like less than 100 similarly. So that patches which we have verified internally can boot up, have the main features like display total in one patch set. As soon as the SOC is announced, we push it at the same day to enable the community to try it. So yeah, we are doing that now.
So you are saying that we could have a decent platform which runs mainline Linux?
We are trying to enable more and more people to do that. But yes, recently we still have like advanced features. Not, for example, we cannot say at the announce day, you can use the advanced Android feature at that day. But the Linux kernel, yes. Pure kernel, yes. So you can put up the latest kernel on top of it. So for example, when we push the patches, it is like based on the like 2 weeks Linux next tag was verified to boot that up.
But should I be able to test most of these on really any board, or would that be on very specific Qualcomm boards? I think maybe the question is, how is it easy to actually get hardware to actually test these things? Would that be on the specific Qualcomm board, or are there the code actually quite generic?
It's a good question. So we do have, for example, it can do benchmarks. Yeah, you can have benchmark numbers, but for example, we have the other functionality is not that ready, like suspend, idle. Yeah.
Yeah, because I mean the problem is always when we start to involve Android and Android workloads, even if you have that automated test case, actually, they are also about that the Android builds that would be available to that board. They have to, from everywhere, be of varying quality. That's like my main question about this. How I think for most people, because it's okay, the code is there, things like that. But I mean, if you actually not run it, it's hard to muster interest of actually testing it, right?
Yeah, so actually we are working on that. That means, yeah, we have teams trying to set up the CI on top of it and trying to make it working continuously, and trying to, for example, we are trying to do more early upstream before, for example, some patches can be uploaded before the SOC announce, something like that. Yeah, so yeah, it is not that perfect now, but yeah, it improved a lot now. Yeah, come back to WALT. Yeah, so how to differentiate the feature category, like for example, which kind of feature is worth to take more time for us to do the comparison, right? And to explain, for example, if it is a use case for gaming or use case for a specific scenario, is it worth to say it do get beneficial instead of those benchmarks? Then it will be a specific. If we are build benchmark on top of the specific scenario, it is still a scenario.
Yeah. Right. So basically, it's not a generic. But the question is, it's like kind of where I said, it's a scenario, but is there a lot of different scenarios that are characteristically like that one scenario? Again, focusing more on the desktop or the phone has a limited scenario. Like I always said, it's always based off of one person working with a device. And you want everything to make that, basically interactiveness is like the #1 priority, usually in that scenario. Whereas like a server, it's more or less fairness because you're dealing with, different requests from different, lots of different people. So I think it is worthwhile if you have like a benchmark, because then people could actually look at that benchmark and say, okay, can I make it more generic? To say, hey, this is how you want. If you have like a sort of normal game, like most of these interactive games have almost the same type of characteristics. And if you have a generic benchmark that kind of emulates that, I think that's worthwhile. But again, I'm starting to wonder, like, is WALT different than PELT, or is just the fact that you knew WALT and then you just built everything on top of it and focused everything to make WALT look really great, when you could have actually done the same thing with PELT, but you just didn't have the hooks that you needed, and maybe you had trouble pushing it upstream at the time. I don't know, or maybe they didn't think about it. So
yeah, but so I still think that it's better to focus on stuff that's missing entirely. Like instead of replacing one thing with a similar another thing.
Yeah,
trying to do so. Just focus on stuff that is not there at all.
Like basically the quality add, the stuff that's built on top. Is it possible to build that stuff on top of PELT?
Of the existing. Instead of building it on top of WALT, can you do it? Can you say, like you said, the view clamp max works with WALT as well as with PELT, right? Maybe there are other things that
Just prefer idle.
WALT as well as with PELT, and then you could more easily convince people to adopt those, because
and just communicate with us, and they say, hey, this is what we have. This is the interfaces that we interact with the kernel. This is what's missing from the kernel. Is there like help us?
I really focus on stuff that is missing or doesn't work for you specifically, and and on the reasons why, because there is some work to do that, right? But you basically need to have arguments like, this doesn't work, this is insufficient for us because of XYZ, right? And that's how we address this. And then we can talk, because then people will ask you, can you do this instead of that, or something similar, right? Because, if you want somebody to deal with a large code base and really try to figure out how it works and as one piece, essentially, then this is not going to happen, because nobody has so much time to do that. So you need to go piece by piece. And the pieces that are easier to start with are the pieces that are missing in the kernel.
If you could come up with a list of those features, like prefer idle, you mentioned prefer prime core, what was there as well? uclamp min, but slightly different from WALT.
Latency hints.
Right. Yeah. So if you can list all of them, we can probably check them. What's the reason for you, why they exist? And we know about some of those problems. There's another one, this extra headroom. So you might remember, we have this config for plus 20%, but some of the platforms, they are pretty aggressive and they can change this for 30, 40. So you don't want to load the CPU that much, because then you up migrate earlier. So it also helps to avoid the situation when the PELT signal is noisy, and sometimes you actually exceed the capacity on your CPU. So you actually prefer to migrate some, let's say, average task earlier to some other core, mid-core or bigger core. So those are the moments, but yeah, you would have to list them, ideally with this list of day of usage applications. And in ideal world, you provide an open source platform so we could check.
So maybe next year we have many topics here, like features per features.
Yeah. Well, but yeah, then we could say maybe the WALT is not the main problem, but it's on top, which are missing.
Yeah. So scenario per scenario, and feature per feature. I think it's a more detailed explanation, maybe not only list. because you will have follow-up questions like, yeah, what's that scenario and benchmark and.
Well,
Yeah.
yes, but that would be on front of the trace. So
Yeah.
if we can capture the trace from this open source platform, then yeah, we could have a technical discussion. But if we just talk about generic design of the software, then I don't think that we will go further.
Yes.
Yeah, you need data.
Yes,
You have to have data to
Trace.
have argument.
Yeah.
Yeah,
So
we can measure and compare.
yeah, good suggestions. Thank you.
So hopefully you're taking notes and bringing this all back.
I think it's recorded.
Yeah, it's recorded.
Yeah.
Well, thank you.
Okay.
Thank you.